All righty. Move on to section 2, and that is limit theorems. All right, so there are theorems that allow us to calculate limits quickly. Here's some are. I'm going to go quickly through these. If you want to write them down and I'm going too fast, you can always pause the video. But if f of x is equal to a constant, so y is equal to, like, let's say 3, that means you've got a horizontal line. And so the limit as x approaches anything is just that y value. So the limit as x approaches c is just some value for x there of f of x. It is just whatever that y value is. So if f of x equals a constant, then the limit as x approaches anything, it's just that same number. Limit of a constant is a constant. If your function is x to some power, where m is a positive real number, right? So like x squared, something like that. Then all you got to do if you're taking the limit as x approaches some number is to plug that number into the x, and your value is just that c to the m. So the limit of x to a power is that number to a power. We saw that yesterday with when you're plugging in a value into a polynomial, or if you have a polynomial, you can just plug the value in. All right, so let's look at these limits. This is 2 truths and a lie. 2 of them are true. One of them is false. And pause it for a minute and take a look at each of them. Pause the video. And hopefully you paused it and took a gander for it for yourself. This is the limit of 10 as x goes to 3. So 10 is a constant. So this is an example of this first theorem right here, where your y value is just 10. So that's a horizontal line going through y equals 10. And as x goes to 3, anywhere on that line, as x goes to any number on that line, the limit would be 10. And so that one is a good one. Yep. Hopefully you saw this one was an issue, but let's go over here. As x approaches 2 of the function x to the 5th, you just plug a 2 in, and 2 to the 5th is 32. So that one is good. This one is the issue. And why is it an issue? Because when you take -3 and you cube it, it's -27. So that one was the false one. All right, so knowing these two basic rules we can combine them and get more intricate functions using the next rules. And again, I'm going to go quickly through these guys because do you have to write them? No, but you need to know that they exist, right? So if the limit of some function as x approaches c is L, and the limit of some other function, so this one's g of x and that one's f of x, but as they're going to the same value as they're both going to c, if those limits both exist, then there should not be a G right there. That's all typo. That's weird. The limit of the sum of the two functions as x approaches c is equal to, you can add the limits together. The limit of a sum is the sum of the limits. G also. That's so weird. That should be like just like a dot or something. I don't know what these G's are. Okay. You can subtract them. Take the limit of the difference, and the limit of the difference is the difference of the limits. And again, this G should just be a bullet point, and it somehow turned it into a G for some reason. The limit of the two functions being multiplied together, you can just multiply their limits together. The limit of a product is the product of the limits. And then also, and again, that should be a bullet point, if you divide the two, you can just divide the two limits as long as the limit of G down here is not 0, because we can't divide by 0. So the limit of a quotient is the quotient of the limits. All right, pause it right now if you want to write all of those down, because I'm going to keep going. Okay. These theorems make it easier to evaluate this guy, right? It's those theorems that say to us that when you've got a polynomial, you can just plug it in, because this. So instead of writing this, which don't write it because it's a pain in the butt, right? If I go to take the limit of x squared plus 3x minus 5 as x goes to 2, technically, you'd have to do the limit of x squared as x goes to 2, and then the limit of 3 as x goes to 2, and then the limit of x as x goes to 2, and multiply those guys together, and then subtract from it the limit is 5 as x goes to 2. Oof. Who wants, and then you got to compute them all separately. Super big, pain in the butt, too much writing. Instead, those theorems that we just learned allow us to we can plug our limit right into the polynomial. So 2 squared plus 3 times 2 minus 5 ends up giving you 5. All right. How about this one? We've got a rational function now. Well, as long as the bottom, the denominator, doesn't go to 0 when we plug that 4 in, then we can just plug the 4 in to this guy. So what happens? You'll have a 4 squared minus 2 times 4. We're golden. We can just plug in a 4 straight into this function, and you would have 4 squared plus 5 divided by 4 squared minus 2 times 4. And that gives you 16 plus 5 over 16 minus 8, which will give you 21 over 8. And I would just leave it like that. So that's what these theorems make it nice, that when it's a polynomial, we can just plug it straight in. And even if it's this guy is a rational function, as long as we're not getting a divided by 0 here, we can just plug the value in and it'll be fine. All right. Hopefully you remember, I think we've talked about this, that the limit of, of 1 over x, as x goes to infinity, is 0. So as you plug in really large numbers down here, as the whole thing ends up going to 0. And even if it's negative numbers, when you're dividing by very, very large numbers, but they're negative, it also ends up going to 0. You could also picture the graph of 1 over x. It's that, drooping. Anyway, the y values end up going to 0 on both of those. So this is important. We're going to use those. We did that. I don't remember what chapter we learned that in, but we definitely have done that before. All right, so this is going to help us evaluate limits that go to positive or negative infinity. For example, they ask us to find the limit of this guy. The limit of x squared plus 7x over 3x squared minus 2 as x goes to infinity. So you really can't just plug in infinity. You're technically not allowed to do that, because what's infinity, right? What number are you plugging in to represent infinity? So here's how we do it instead. We've done this before. Do you remember when I would take it and I would divide the top and bottom by the largest exponent in the bottom? So so we've got an x squared down here in the bottom. So I'm going to divide top and bottom of this fraction by x squared. So that means that it's the limit as x goes to infinity of x squared over x squared is 1. That's where the 1's coming from. 7x divided by x squared is 7 over x. 3x squared divided by x squared leaves you with just a 3. And then 2 divided by x squared gives you a 2 over x squared. So now the limit as x goes to infinity of 7 over x, well, we know that as x goes to infinity of 1 over x is 0. 7 over x is just 7 times that. So that guy goes to 0. 7 over x. The limit as x goes to infinity of 7 over x goes to 0. 2 over x squared, that goes to 0 even faster as x goes to infinity. So that goes to 0. And so what you're left with is a 1 plus 0 over 3 minus 0, which leaves you with a 1/3. I did give you the little hint also of when the degree on top is equal to the degree on the bottom, the limit will be that it follows the same as the horizontal asymptote rules, if you remember that. It'll be the leading coefficients on these guys when the degree on top is the same as the degree on the bottom. But this is how you work it out. How about the limit as x goes to negative infinity of x squared minus 5 over 4x cubed plus 2? So what you're going to do, I'm going to do the same thing I did up here. I'm going to divide by x cubed top and bottom, since x cubed is the largest exponent, right? It's the largest degree. So I'm going to divide top and bottom by x cubed, which will give me the limit as x goes to negative infinity of x squared divided by x cubed will leave me with a 1 over x, 5 over x cubed, there. 4x cubed divided by x cubed will leave me with a 4, and then 2 divided by x cubed will leave me with a 2 over x cubed. And then when I plug in a negative infinity in there, um, the limit of 1 over x as x goes to infinity is 0. So this will be 0. 5 over x cubed goes to 0 even faster. So you'll have a 0 minus 0 on top. On bottom, you'll have a 4 plus the limit as x goes to negative infinity of 2 over x cubed is also 0. And so you end up with 0 divided by 4, and 0 divided by anything is 0. Well, as long as it's not 0 divided by 0. But 0 divided by 4 is 0. All right, that's it for today. This is a cute little joke. After explaining to a student through various lessons and examples that the limit as x goes to 8 of 1 over x minus 8 is infinity, I tried to check if she really understood that, so I gave her a different example. The limit as x goes to 5 of 1 over x minus 5 is sideways 5. Get it? Because the 8, when it's sideways, looks like infinity. But no. As x goes to 5, this would be 1 over 0, so it would also be infinity. But anyway. All right. I hope you guys have a fabulous day. Come on. All right. You guys have a good one. Bye.